Variables and data types are the very basis of everything that we do in programming and in computer science, so it's only natural that this is the first thing that you're going to learn in Python. Before I get into any discussion about what variables are, I'm first going to show you what a comment is in Python. You can do this in Python by using the pound symbol. Essentially what a comment is it's just a note that is completely ignored by the interpreter, and most of the time it's used for when you want to describe what's going on in your code for yourself or for other programmers if you're working on a team. I'm going to use these a lot when I'm not necessarily going to program anything, but I want to show you any notes in the series. You can see that the syntax highlighting turned it gray and italicized in my theme. This is just denoting to us that we know that it's a comment. You might remember that in math, whenever you dealt with variables, they were typically letters and you would have to solve for them in an equation. That's not necessarily true with what we do with variables in programming. In programming, when we have variables, it's just so that we can store data to use them for later. In math, you can either have 2 equals x, and x was a very standard variable name in math, or you can even have x equals 2. See, in programming, the first option is not valid. You can only have the name of their variable first and then an equal sign to show that you're setting it equal to the value on the right. This is the assignment operator, which is just a single equal sign, and on the left is the name and on the right is the value that you're setting it to. Using the example that we have above, I'm going to actually create this variable in Python by I'm going to set 2 equal to x, and you can see that x has highlighted red. This shows us that is a variable. If I highlight this in the VS Code, you can see the extension tells us that it is a variable x. In Python, there are very certain rules that you have to follow when naming variables. There are also rules that you don't have to follow, but it is considered best practice, and I will be showing you those in the series because that is also one of the goals of this course, is so that you learn the best practices in Python 3. You can see that I named it x, and it starts with a letter, and that's true for all variables in Python. All variables have to start with a letter. They cannot start with a number, but as soon as you start one with a letter, you can start it with a number. So say I have x2, and I'm going to put that to 3. That is completely legal in Python. If I want to create a variable with multiple words in them, they will be all lowercase and separated with an underscore. This is not required in Python, but this is, like I mentioned before, best practice, and this is called snake case. If I want to give you an example of a variable name with multiple words in it, I'll just say num computers. This will denote to me, say that I have 4 computers. This just lets me know that I have a number of computers and that is equal to 4, and you can see that I have separated them by an underscore. There are also conventions to having constants in Python, and a constant is basically a variable that acts as something that will not change no matter what. A perfect example of this is the number pi that most of you may know of, 3.14159. Constants in Python are typically all capitalized, and you can see that highlighted in orange, the syntax highlighting, and the extension in Visual Studio Code did that for me, and this just denotes that it is a constant. And then when we use a constant, I'm going to set that equal to 3.14159. And you can see that this is now acting as a constant in our code. There is a number of built-in data types that Python does give us, and I will go ahead and go through those now. We're going to first start with the numerical data types, and there are 2 of them. One is an integer and the other is a float. An integer is exactly like I showed you before. It is just a whole number. That means a number without a decimal point, and it can be positive or negative. So if I want to set a variable called y and set that equal to negative 100, that is completely valid, and that is an int. And you can even check the type of any variable at any time or any value by showing the type function. And to output this to the console, we will first call the print function that we used in the previous video to print our message out to the terminal. And then inside the print function, we will call the type function, and I'm going to pass it a variable or a value. In this case, the variable is holding the value of 2 because I'm showing x. So let's go ahead and run this. I'm going to hit the green arrow in the top right, and you can see that it says class int. and this just shows that the type of the variable that I'm having here is an integer. And if I want to pass it y, then you can see that it will also say that it is an int. And it doesn't matter if it's negative or if it's positive, it just has to be a whole number with no decimal point. You may remember in math that when a number got very large, you would separate every third digit with a comma, just like this. Say we have the number 1,000,000. We separated every 3 zeros with a comma. You can try that in Python and see what happens. Say that we have 1,000,000 again. Let's go ahead and print the type and see what happens. When we print the type of this, let's see what it is. Notice that this is no longer an integer, but it's actually something called a tuple. We'll get into tuples a little bit later in this video, and then we'll get into more specifics later in this series. But for now, just note that if you want to emulate this comma-separated number, you can't use commas, you instead have to use underscores. Now, if we print the type of z, you'll see that it is now classified as an integer. These underscores don't add any functionality, they're there just for readability, because numbers can get pretty confusing when you're trying to count them without commas. So this is here for your readability, and you can use them if you want. Now that we've talked about integers, let's go ahead and talk about floats. A float is pretty much the exact same as an integer. The only difference is that it holds a decimal value. Like I mentioned before, they can be positive or negative. So if we want to have a variable called a, and we'll set this to 1.0123, that is completely valid. And if I want to have b and set that to negative 1.0123, that is also completely valid. Something else that you can actually do if I didn't want to have to type in negative 1.0123, I can actually set b equal to negative a. And you'll see that if I print the value of b, then the value is negative 1.0123. It just took what was stored in a and it popped the negative sign right in front of it. If I print the type of b, you'll see that it is a float, like I mentioned before. Float is just a decimal number. Now that we've talked about the numerical data types, let's go ahead and jump into the non-numerical data types, and I'm going to first start by talking about a data type called the Boolean. Boolean is very simple, and it can only be one of two values, and this is true or false. If I wanted to create a variable around this, I'll say maybe is raining, and I will go ahead and set that to false because currently where I live it is not raining outside. If I wanted to say is sunny, I could set that to true because let's say, for example, that it is sunny here. That's just what Booleans represent, is basically a 1 and a 0 in binary. We'll be getting into more Boolean logic later in the series. We'll have a video dedicated specifically to that, but I just wanted to introduce you to the two values that Booleans could be. Let's go ahead and talk about a data type that you've actually already seen before without knowing it, unless you've come from another programming language. These are called strings. We saw these when we were making our first program, and we printed a message out to the console called Hello World. A string is just a sequence of letters or numbers. They're surrounded in quotation marks, and they just represent a series of characters. If I go ahead and print this message to the console, you'll see that the thing hello is printed out to the console. Now I can put whatever I want inside of here. I can put numbers, I can put letters, I can put symbols. As long as it's in quotation marks, it is completely valid. And if I print this message out, you'll see that everything I have in the quotations is printed out straight to the console. Strings can also be surrounded with single quotes, but you'll notice that if I try and mismatch the quotation marks from the beginning, the first ones are double quotes and the last one is a single quote. It says that the string literal is unterminated, meaning that there is technically no end to the string because I didn't finish it with the same quotes. You'll notice that now that I have a ending double quote, that there is actually no error with the single quote inside of the string. That's because if you have a string with, let's say, single quotes, I can actually put double quotes inside because the editor and interpreter is smart enough to recognize that the two double quotes on the inside are not actually closing the string. So I can put this is a quote inside of the two double quotes inside of the string and print that out. You'll see that this is a quote with two quotation marks. It's printed to the console. We'll also be getting way more in depth with strings. There is a lot more to know than just besides that they start with a quotation mark and end with a quotation mark. There is an entire list of things to go over, and we will dedicate an entire video to that later in the series. We'll now be going over two very similar data types called lists and tuples, and we already mentioned tuples earlier, but I'm going to get a little bit deeper into them right now. Lists and tuples both just represent a list of values, and these lists can contain any data type that we've gone over. It can contain an integer, a float, a boolean, and a string, or it can be just all integers, all floats, and so on. Let's say that I have a list called nums, and I'm going to set that to a list of 1, 2, and 3. You'll notice that a list is signified with a square bracket opening and closing, and the values inside of the list are separated by commas. If I go ahead and print nums to the console, you'll see that basically everything that we typed here is displayed right into the console. The equivalent of that in a tuple form would be like if I made a variable called nums2 and I set that equal to with parentheses rather than square brackets, and I did 1, 2, and 3, and then let's say that I printed that to the console. Let's see what the output is. You'll notice just like the list, it's just with parentheses, but it has the same exact values. Tuples, like strings, can put any sort of data that you want in there. So let's say that I just have like a values variable, and I have here 1, 2, and I have a string with like a name in it, and I have true here, and I put 0, 1, 2, 3 in there, and then let's go ahead and print values to the console here. You'll see that that is a completely valid list here. The main difference between tuples and lists is a very interesting one, and something that you do have to keep in mind when you use tuples and lists is that lists are mutable. What do I mean by mutable? Well, mutable means that you can add values and remove values. It just means that it can be changed. A tuple, on the other hand, is immutable, and that is the exact opposite of mutable. It means once you have declared a tuple, that is all you have right there. You can't add values, you can't change the values, you can't remove the values, and you're essentially stuck with what you declared. We'll be going into lists and tuples way more in depth, just like the strings and the booleans, in a separate video later on, because like strings, they have just a lot of more information and things that you can do with them and that you need to know about them before really using them in your program. We have another data type that's kind of similar to lists and tuples in Python, and it is actually called a dictionary. Dictionaries essentially hold key value pairs. What this means is it basically holds essentially a list of variables. You can think of it like that. Let's just get right into an example. Let's say that I have a dictionary called grades, and you can see that I'm signifying that this is a dictionary with the curly braces. And if I want to put values in, I'm going to go ahead and open up a new line, and this is pretty standard practice in Python to add values. Let's go ahead and say that I'm a teacher and I'm inputting grades into this dictionary that I have, so I'm going to have the key be the student's name and then the grade be the value. So let's say that I have a student named Bob, so I'm going to put his name in for the key, and I'm going to put in a string because that is the data type that would match a name. And then to signify that I'm giving him a value, I'm just going to put a colon here. I'm going to separate it by a space. You can keep it here or space it. I just like to have a space there. And then let's say that he's doing really well, so he got a 100 on a test or something. Now I'm going to separate this by a comma, just like a list and a tuple. This just signifies that I'm moving on to the next pair in our dictionary. let's say that I have a Sally, and she's not necessarily a very good student. She got a 50 on this test that she took in class. Same thing, have the key being a string with her name, and then the value being an integer with her score on the test. Let's have one more student, and let's say his name is Jimmy. And he did okay. He did pretty well on the test. He got an 80.4. He got a like a partial on a question or something like that. That is completely legal. You'll see that there's no errors in the code here. You can, just like lists, put as whatever data that you want in here. Let's say that, like, with the grades, let's say that I have something called like maybe a string called like is passing. Maybe I want to know if I'm like, as a teacher, I'm being a good teacher and all my students are passing the class. Let's say that it's true because I have a pretty good range and I forgot to actually put the comma here. You'll see this is completely valid too. I could also pair a number here. So let's say that we have a dictionary, and I'm going to actually move this to a new dictionary. So like, let's say that we're working with employees and I want to have like an ID system. So I want to pair their ID with their name in like a database or something. So let's go ahead and say that we have like the ID is like the very first person here. So I have the ID is 1, and then maybe the value is John. John has the employee ID of 1, and then we'll do like a Sarah, and actually that's the value. She has the employee ID of 2, and so on and so forth. This is just a demonstration to show you that you can mix and match types in dictionaries. Usually when I'm dealing with dictionaries, it's important to know, for me, I can obviously tell what the data types are going to be when I look at it, but maybe I want to help signify what the actual values are representing. So maybe I'll make a comment here that says like ID and then it's employee name or something like that. This is just a comment for myself to help me understand what these values are representing in dictionaries, and I encourage you to do this because it might help you out or anyone else out that is reading your code. When we print out dictionaries, let's go ahead and print out our grades and run that, and you'll see that I did it on multiple lines just to show like readability so that you can read it easier. But when you make a dictionary in Python and you output it, it will just put it all on one line. We actually have one more data type that is in Python. It's kind of weird to call it a data type because it's actually called the NoneType, and this represents, well, basically like it says, it represents nothing. Let's say that we have like just like pizzas or something. The way that I signify none is with none, like the word with a capital N. See that the syntax highlighting has picked it up. And usually this is used for like placeholders in your code. Let's say that you don't necessarily have anything for it quite yet, but you will later in the code. None just acts as a placeholder, especially when you're using objects and you don't have an instance of an object to set it equal to yet. And while we're mentioning objects, it's important to note that everything in Python is an object. You're not going to know what that means now unless you've dealt with object-oriented programming with another language, or maybe you have some knowledge on it yourself. Let's go ahead and take a look back at the output that we had earlier, and you'll see that whenever we called this type function here, you'll see there's a keyword here that says class. What's a class? Well, essentially all you need to know for now is this denotes that it is an object type. You'll see that this variable here was in the class int, which it is an integer object, essentially. That's as far as we're going to get into that right now, but we will have, towards the end of the series, multiple videos over object-oriented programming where we will get way deeper into classes and objects. If we go ahead and print the type of pizzas, let's go ahead and see what the none type is actually represented in a class. You'll see that it says that the class is none type. So it's not none, it's none type. We'll kind of be talking about the none type a little bit when we get into object-oriented programming because, like I mentioned before, it's very useful if you want to set a temporary value to a variable that's supposed to be an object. If you watched my video on the Python programming language, you might remember that I mentioned that Python is a dynamically typed programming language. Dynamic just means that at runtime, the interpreter will find out what the value and the data type of the variable is, so we don't have to tell it what it is ourselves. Because it's dynamically typed, that means that we can actually set variables to different data types later on in our program. If we go up here and we see that x is equal to 2, well, let's go ahead and redeclare x to a string, we'll say. So I can redeclare it down here, and you can redeclare variables as much as you want. You can just put the name of the variable like it was and then just use the assignment operator again and set it to a new variable, and this will work with any type. And then let's go ahead and print x again and see what happens. You'll see that it printed out Bob. That's because Python is dynamically typed, and the interpreter, to be quite frank, doesn't care what type the variable is. This could be useful to some depending on your project if you want to redeclare variables with different types. I typically stay away from that just to keep it more organized for myself, but that is available to you if you do want to use that. Now that we've learned a little bit about using variables in Python, we will be using these a lot more throughout the series because, like I mentioned before, variables are the basis of just about everything that we do in programming. Since we also have gotten very comfortable using the print function to output information to the console, in the next video, we will be talking about how to take input from the user and use it in our program and manipulate it to what we want it to do.